ず歌うヘッドライト。新旧の歌謡曲を中心に道路情報。
10月17日木曜日、おはようございます。原田ゆかりです。寒くなりましたよね。皆さん風邪なんかひいてませんか？昨日私は山梨に行ってたんですけども、朝駅のホームで寒くてね、電車を待っている間ずっとガタガタ震えてたんですけどもね、これからはもっと寒くなるんですもんね。
Vehicles are on the move around the clock. People want to get to their destination quickly, and they want to get there safely. The electrical system plays an important role in meeting these demands. It helps to give vehicles the versatility and performance they have today. Do you find electricity hard to understand? Well, if you take each part of an electric circuit separately, it's really quite easy. Current flows from the positive side to the negative side, doing the job required of it on the way. What we're looking at is the basic electric circuit. In a vehicle, the main source of electricity is the battery. In passenger cars and light trucks, it's a 12-volt battery. In larger vehicles, there's more work to do, and two 12-volt batteries supplying 24 volts are necessary. This is the lead from the negative side of the battery. Watch what happens when we connect it to the chassis frame. In fact, the electrical system of a vehicle is designed in such a way that the negative side is the chassis frame. This means that the only leads that need to be installed are the ones on the positive side. Let's take a look at the electrical system of the whole vehicle. When you turn the key in the starter switch to the start position, the starting system operates. In a gasoline engine, the ignition system operates at the same time and the engine starts. The charging system takes power off the engine and generates electricity. This electricity is used to operate the headlights, the horn, the windshield washer and wipers, the air conditioner, radio, and other accessories that run on electricity. Some of this electricity is also used to charge the battery. This is the whole circuit diagram. Starter switch on. The engine starts. The starting system brings the engine to life. What makes the starter motor turn? Let's think about that first. A simple magnet. If we sprinkle iron fillings around a magnet, we can actually see the magnetic lines of force. Unlike poles are attracted toward each other. Like poles repel each other. Attraction and repulsion. The poles of the free-moving magnet are attracted to the unlike poles of the stationary magnets and repelled by them when its polarities are reversed. If you get the timing right, you can keep the magnet rotating smoothly. When current flows in a coil, the coil becomes an electromagnet. With this type of magnet, you can reverse polarities simply by interchanging the positive and negative leads from the battery. With an electromagnet, polarity can be reversed quickly. Brushes and a commutator are employed to reverse the current. By matching polarity reversals to coil movement, smooth revolution can be achieved. This is the principle of the electric motor. Now, let's take a look at the whole starting system. When you operate the starter switch, the magnetic switch closes, engaging the starter motor pinion with the flywheel gear. Simultaneously, the starter motor rotates, kicking over the flywheel, which turns the engine over. That's all there is to the starting system. Sparking occurs when an electric current jumps the air gap between 2 points. To generate a spark, high voltage, about 20,000 volts, is required. This high voltage is produced here in the ignition coil. The thick wire is the primary winding through which current from the battery flows. The inside coil, consisting of many turns of fine wire, is the secondary winding. If we cut off the current in the primary circuit, an instantaneous high voltage is induced in the secondary winding. This high voltage is fed to the distributor, from where it is sent, in turn, to each spark plug. The distributor has a contact point for each spark plug. The relationship between the actions of the distribution and breaker mechanisms is automatically controlled so that sparking occurs at exactly the right time for all engine speeds and loads. Well, that deals with the ignition system. What is required of an electrical system is that it be self-sufficient. As well as consuming electricity, it also has to produce it. A simple experiment will illustrate the basic principle of an electric generator. When current is supplied to a motor, the motor rotates. And vice versa. If the motor is mechanically rotated, the motor will function as a generator. A generator is, in fact, a motor operating in reverse. As we see, when a magnet is moved near a coil, a current flows in the coil. This phenomenon is put to practical use to generate electricity. The generator in a vehicle utilizes engine rotation to rotate a magnet, which, in turn, generates electricity in a coil. The pointer of this meter swings in both directions. Current that continually changes direction is called alternating current. But battery current does not change direction. That's why we call it direct current. Therefore, alternating current cannot be used to charge a battery. This problem is overcome by inserting a diode bridge in the circuit. Now, the current flows in only one direction, and the magnitude of the swing is reduced. This is the diode unit or rectifier in an AC generator. Now we can produce direct current. The magnitude of the current generated by an AC generator varies with the speed of rotation. This is something we have to overcome with all AC generators. Here we have a rotating magnet. The strength of the magnetic field produced by an electromagnet depends on the amount of current flowing through the coil. When the AC generator is rotating slowly, by supplying more current to increase the strength of the magnetic lines of force, we can obtain a higher output voltage. On the other hand, when AC generator rotation is fast, reducing the current will weaken the magnet and decrease output voltage. This function is performed automatically by a regulator. This is a good point to summarize the whole electricity generating system. Alternating current produced by the AC generator is rectified by the diode bridge, and the resultant direct current is stabilized by the regulator. Some of this current is used to charge the battery. Self-sufficiency, that's what the charging system of a vehicle is all about. When the pointer moves to the negative side, battery electricity is being consumed. When it moves to the positive side, the battery is being charged. The overriding consideration when driving a vehicle is safety. Herein lies the most important duty of the electrical system. You can't drive at night without headlights. With the turn signal lights, you can indicate your intention to other road users. The horn gives warning of your approach. The windshield wipers give clear forward vision. The defroster clears the windshield in next to no time. As well as these essential fittings, there are other electrical accessories provided for greater driving comfort. Speed indicator lights, required by law in some countries. Various kinds of meters and gauges to inform you of the current status of the engine and other equipment. After conversion into light, sound, mechanical power, and heat, electricity serves a purpose in many parts of a vehicle. The degree of difficulty a current experiences in passing through an electrical conductor is a measure of that conductor's resistance. Increasing the current will cause the conductor to heat. That's how the cigarette lighter in the dash works. The filament that melts the frost on the rear window. And the preheating system in a diesel engine. If we keep increasing the amount of current flowing through a conductor, it gets hot, and finally, a section melts, breaking electrical continuity. In a glass envelope filled with argon gas, by enclosing a filament that glows to incandescence but does not burn out when a current passes through it, we have the electric bulb. Turn signal lights have a specific brightness, color, and flashing frequency. A vehicle must, by law, be fitted with taillights and stoplights. There are many types of electric bulbs available, and you must always make sure you use the specified type when replacing one. For the headlights, a shield beam type bulb, lens, and reflector, integrated as one unit, are used. Optimum degree of brightness and beam angle are carefully worked out and accurately adjusted on every vehicle before delivery. There is always a fuse on the electrical source side of each circuit in a vehicle's electrical system. When you experience trouble with the electrical system, you should always check the fuses first. When a current larger than that specified flows through a circuit, the fuse melts and protects the circuit by breaking electrical continuity. Do-it-yourself remodeling of the electrical system to accommodate extra lights or electrical equipment invites trouble. For reasons of safety, it is not recommended. Always seek the advice of your Isuzu dealer. This kind of remodeling will drastically shorten the service lives of the generator and battery, and what's more, overload the electrical leads. Presenting a fire hazard, the heat generated will eventually deteriorate the insulation. Even though the voltage involved is low, you should always treat it with respect. The fuse is the electrical safety valve. Always make sure that you use a fuse of the specified rating. You'd be surprised how many people are fooled by a dirty fuse contact or a loose fuse holder into thinking that they have serious electrical trouble. They obviously haven't taken the trouble to read the caution plate. What do you imagine gives the most trouble? Trouble, in fact, caused by negligence, too. Well, it's our old friend, the battery. Is the level of the electrolyte correct? The specific gravity of the electrolyte must also be correct. Corroded and loose terminals. And don't forget to periodically check the tension of the fan belt. Take care of your battery, and you won't have to use another vehicle to start yours. But if you do, first confirm that the other battery is the same voltage as yours. Using the correct capacity jumper cable, firmly connect positive terminals to positive and negative to negative. So as not to short the good battery, be careful that the positive jumper cable clip does not touch anything other than the positive terminal of the battery. A vehicle's electrical system looks complicated, but really, it's only a combination of simple circuits and application of very basic principles. Vehicles on the road at the present time incorporate improvements gradually introduced over the years. As in the past, Isuzu engineering will continue to be a force to be reckoned with in the drive toward automotive perfection. Today, there is a need for safe vehicles that help to save energy and reduce pollution. The electrical system will play its part in achieving these goals.